Hi, everybody. We're learning a new concept now called the null space. So what is a null space? Well, funny you should ask. We know that a system of simultaneous equations, which we represent in matrix form as A, x equals B, A is an m by n matrix, x is a vector, and B is a vector. We know that this either has 0, 1, or infinite solutions. We've established that. However, if B is 0, the vector, so we have what's called a homogeneous system of equations, then we know it's 0 or infinite, because we know that there's always at least one solution. There's no such thing as no solutions, because if x is the 0 vector, then that will always be a solution. Meaning, say, if you have a system of simultaneous equations, and I make x, y, z, and everything else equal to 0, then everything's going to be 0, and that's going to be a solution, assuming it's a simultaneous equation, which means I have all zeros on the right hand side. Now I'm claiming that the set of all solutions of a system AX equals 0 forms a vector space. And here is the proof. Since A is an n by n matrix, and x, then that means x is an n by 1 vector, so it's a subset of Rn. We've already established that it's non-empty because, like I said, the 0 vector always works. Now I have to show that it's closed under vector addition, scalar multiplication, which is not hard to do. If x1 and x2 are both solutions to the homogeneous equation, meaning ax1 equals ax2 equals 0, then ax1 equals ax2, which equals the 0 plus 0, which equals 0. But I could also do distributive law here, because that works, and I get a times x1 plus x2. But that means that x1 plus x2 is a solution of the homogeneous system, so therefore our set is closed under vector addition. Further, if I look at the vector cx1, then c a times cx1 is equal to c times a of x1, which is c times the 0 vector, which is the 0 vector, which means that our solution set is closed under scalar multiplication. Therefore, our solution set is a vector space, and that vector space is called the null space of A. Yay!